Hi, we are trying to convert alkyl group on the benzene ring to a halo compound or bromo alkyl group. And what you do first, you react with permanganate, and the acidic permanganate will convert any R group, ethyl, methyl, propyl, butyl, anything like that, into a carboxylic acid. Now you have the carboxylic acid, you're going to do a reduction using lithium aluminum hydride and hydrolysis of it. So now you're going to get the alcohol. You see the double bond O completely gone because we have 4 hydrogens, hydrides actually, right? So you see the 2 hydrides attached where it is, right? Now if you have an alcohol, pretty easy, react with phosphorus tribromide to get the bromine instead of the OH. Now, if you have the bromo compound, that's it. Then you can actually make the Grignard from it. So let's look at the next part of the question. So these are randomly I picked up. Some of them are very basic conversions. Some of them are a bit complex. Now, so this one we have benzene ring and still the alkyl group attached, and then it converting into a triple bond and to another ring, benzene ring, but that also has an R group, alkyl group. Now just pay attention. Sometimes this is critical. When you have a triple bond, the bond angle is 180 degrees. It's better if you're aware of that. Now, so again, any alkyl group sitting on a benzene ring, you react with acidic permanganate or potassium permanganate, and then it'll make carboxylic acid on it. So only one carbon will be remaining on the alkyl chain, and then it'll be oxidized fully to carboxylic. Now you can actually reduce into an aldehyde. It should be controlled conditions. Lithium aluminum hydride should work under controlled conditions. Now you can use magnesium and ether and a suitable Grignard reagent. So because we need para position, and you have we previously produced this ethyl bromo ring, and then you convert that one using magnesium ether, dry ether, and then it will react as a negative from the CH2 attached to the bromine, right? Because there's magnesium ether complex there. So now it attaches to the aldehyde, the benzaldehyde, and now you have an alcohol group. So this alcohol group you can replace with the PBr3, so that means Br, and then this is a couple of steps here, right? So first you can actually remove, even with conc sulfuric, you remove the water molecule, and then you can add bromine, which is a much faster method, and then the bromine you can remove as HBr with hot KOH, and that's how you get the triple bond. Okay, so you can stop the video and give it a try, and there are other methods too. So this is a faster, simpler method. Now let's look at the next question. So we're starting with benzene, and we're going to end up with, let's see here, it's a Grignard reagent, right? So now preparation of benzyl, it's called the benzyl, it's not benzene, benzyl Grignard reagent. So how do we do that? So you can react simply with methyl bromide and aluminum chloride. That's a Friedel-Crafts alkylation. We talked about that few days ago, and now you just attach the methyl group or any relevant alkyl group. You can do it that way. Now you can react with, in the presence of UV, bromine substitution. So that's the free radical reaction. You have the bromide attached to that one. Now just add dry ether magnesium, you're going to get the Grignard reagent that you need. So this is a good one, so stop it and see whether you can create different types of Grignard reagents. And so only you need dry ether and magnesium and halo alkyl groups. Okay, so this one, you start with benzyl alcohol. This one is called benzyl alcohol. If you don't need to know the name, just the OH is not on the ring, but it is on the alkyl group. Now we're going to make a double bond attach to that and another ring, right? Again, the OH can be converted to Br using PBr3. If you use SOCl2, we call the suckle. If you use the suckle, you're going to get the Cl. Either way, you have the halo compound. Now you add dry ether with magnesium, and then you make the Grignard reagent. So you have one Grignard reagent. So we did produce this type of Grignard reagents a couple of times. Now you have to get the suitable aldehyde, right? So alcohol can be, it's a primary alcohol. Primary alcohol can be converted to the relevant aldehyde under mild conditions, pyridine chlorochromate, or simply known as PCC. So if you have PCC, you make the aldehyde. Now Grignard reagent R negative going to attach onto the electrophile of the carbonyl, and it attaches, and then you end up with this compound, this connection. Now if you heat and remove the water molecule, then you can get the double bond, right? So you can go further, you can replace the OH, you can have a triple bond as well, and that's another possibility, but that's what we need here. Okay, PBr3 and bromine added and heating with KOH will give you the triple bond. Thank you.